movement. Silent Spring, Carson's seminal investigation of the toxic dangers of pesticides, traded on the powerful imagery of nuclear weapons, as well as public familiarity with their dangers. So, in the opening chapter to Silent Spring, Carson wrote of a Midwestern Optimo laid waste by mysterious poison. Animals, plants, even humans have fallen sick or died, and Optimo lies silent. The culprit, we find, is a white powder that had accumulated, that had, quote, fallen like snow upon the roofs and lawns, the fields and streams. But that depositing wasn't the act of a malicious foe. No witchcraft, no enemy action had silenced the rebirth of new life in this stricken world, Carson tells us. Rather, the people had done it to themselves. So the snow in Carson's story, unlike the snow that had befallen the Lucky Dragon, was the product of Optimo's own residents and the pesticides that they had showered upon their crops. In addition to using nuclear toxicity as a metaphor, Carson relied on public familiarity with the radioactive toxins to transfer concerns to pesticides. Strontium-90, she wrote, released through nuclear exposure into the air, comes to Earth in rain or drifts down as fallout, lodges in the soil, enters into the grass or corn or wheat grown there, and in time takes up its abode in the bones of a human being, there to remain until his death. Similarly, chemicals sprayed on croplands or forests or gardens lie long in soil, entering in a chain of poisoning and death. Of course, as we know now, the concentration of toxins in our bones depends a great deal on where those bones spend their time. And thus, the agricultural workers who enter fields sprayed with pesticides face a far greater risk than those who wash and eat the strawberries that they pick. But that perception that Silent Spring fostered of a poison even more prevalent than nuclear toxicity helped catalyze modern environmentalism. Informed by advances in ecology, environmentalists began to establish inescapable biological connections between humans and the physical environment, with some offering a holistic rendering of human society that linked humans in these sorts of ecological chains. Continuing a critique first articulated by opponents of nuclear testing, environmentalists warned of the potential dangers of the wide dissemination of industrial chemicals. For environmentalists, the threat of permanent or irrevocable poisoning was a key concern, expressed in the Cold War motif of a toxic time bomb. A toxic time bomb in which an undetected sequence of events becomes irreversible before anybody realizes what has happened. New awareness of the process of bioaccumulation, whereby toxins grow increasingly concentrated as they move up the food chain, only fanned these fears of irreversible harm. That same St. Louis organization, the one that had collected all those baby teeth to track the spread of SR90, expanded its focus to industrial chemicals. And its newsletter, its nuclear information newsletter, became Environment, one of the most widely read and influential publications in the environmental movement. And one of its founders, Barry Commoner, went on to become a quite prominent environmentalist. Now, for environmentalism, particular poisons like PCBs proved an easier target than modern industrial society as a whole. And for a number of reasons that William Leach helped us to understand, the barriers between consumers and the industrial process of production remain extant. So this slide is of what you might think of as sort of the vernacular landscape in which toxins are produced. So this is one of many thousands of municipal landfills across the country. This one in Miami-Dade County in Florida. And by the 1980s, over 3,000 tons of consumer waste were being deposited at this landfill every day. And as you'll see from the Langston reading, many of the plastics that we throw away contain these endocrine disruptors and other chemicals that have profound effects, potentially profound effects, on the human body. And yet, the imperfect holism expressed by those environmentalists continued to serve as an animating force of environmentalism, and it remains a key inspiration for our understanding of the toxic landscape. So in Nancy Langston's chapter that you'll read, she discusses endocrine disruptors. And she reveals how synthetic substances like PCBs and ethinyl estradiol, the estrogenic compound in birth control pills, and even the caffeine mixed into our soda have profoundly altered the biological basis of gender in organisms ranging from the mosquito fish to the Florida panther and, most troublingly, to modern humans. As Langston writes, endocrine disruptors connect environmental histories of the body with environmental histories of wild places and wild animals. What we eat, what we drink, what we excrete, how we procreate, these are at the core of our animal selves. Our bodies are how we're most natural, but now they're also how we're most industrialized, since our bodies are where our industrial chemicals are coming back to haunt us. Inspired by such holistic thinking, environmentalists in the 1960s demanded new regulatory protections against the dangers of industrial society. These and other environmental concerns held wide popular support and inspired early legislation, such as the Clean Air Acts of 1963 and 1967, the Clean Water Acts of 1960 and 1965, the Endangered Species Laws of 1964 and 68, and several wilderness laws, including the Wilderness Act of 64 and the 68 Wild and Scenic Rivers and Hiking Trails laws, and the development of Redwood and North Cascades National Park. So you don't need to worry about writing all that down. But most importantly, this new environmentalism helped spur the creation of the Environmental Protection Agency in 1970 to administer this bevy of new regulation. Under its first directors, the EPA proved far more proactive than earlier regulators in addressing the sources of industrial pollution. But while environmentalists succeeded in transferring regulatory authority away from agencies that they considered overly beholden to industries, the creation of the EPA as a more independent regulator addressed only one aspect of the problem. Except in egregious cases, like the Lucky Dragon's exposure, definitive causation is very difficult to establish in toxic poisoning. And there's a number of reasons for this, but chief among them is that it's impossible to do a controlled test on the human health effects of industrial toxins, because to do such a test would be unethical, or to expose humans in such a test would be unethical. And so what researchers have to rely on are epidemiological studies of populations, which obviously are not controlled. And so many of these tests focus on particular groups of workers who have been exposed to toxins, and another set use lab animals to try to, as a proxy for humans. But the problem with using lab animals is one, they're not humans, but two, the way that to test how sensitive these chemicals are, they often test in far greater dosages than humans would ever receive, unless they were, for instance, on the Lucky Dragon. And so it's the connections, the correlations that people have established between various toxins and human health effects are quite strong, but causation remains impossible to establish. And so this uncertainty forms an uneven, or I guess, an unstable foundation for regulation. By the mid-1970s, scientific debates on toxins had largely coalesced into two camps. One that was comfortable making recommendations based on this emerging science, this emerging uncertain science, and one that demanded absolute proof. Regulatory debates often centered on where the burden of that proof should lie. And the workplace, with its concentration of toxins, often served as the battleground. In many production sites, synthetic compounds presented a new threat to workers. Company doctors often refused to divulge information on exposure to workers on the grounds that it was privileged information, that by telling workers what concentration of toxins they'd accumulated as a result of their labor, that they would potentially be tipping their competitors off to their manufacturing process. This withholding of information might be thought of in a long 20th century history of workers losing control over the knowledge of production. So whereas we learned in the late 19th century, early 20th century, in these Taylorist remakings of factories and the instantiation of assembly lines, workers lost control over the knowledge of the production process. In the middle of the 20th century, as workers began to come into more and more contact with these synthetic compounds, they lost the knowledge over the dangers inherent in that process. So whereas an operator of a press might be able to recognize that if my hand goes in this press, I can lose a finger or lose my hand. Workers handling, say, asbestos in the 1950s did not yet know that what they were handling was a carcinogen. So this slide here is of the Rocky Flats plant, and there's a couple things I want to demonstrate here. One is we've talked about this shift, this federally funded shift of industry away from traditional manufacturing industries like the Northeast and toward the West and the Southwest. And the Rocky Flats plant is a great example of this. So the Department of Energy hired Rockwell Industries to produce plutonium at this site. And Rockwell Industries produced an enormous amount of plutonium, something on the order of 50,000 plutonium cores. So each of these cores being capable of serving as the material for a nuclear weapon. Now, plutonium is extraordinarily toxic to humans. 1 gram of plutonium is enough to cause cancer, just inhaled. And Rockwell turned out to not be the best employer when it came to safety standards, with a series of fires racking this plant in the 1950s and 60s, including one in the late 50s that blew out the entire filtration system, putting an unknown amount of plutonium into the air. The Atomic Energy Commission, relying on Rockwell Industries, claimed that this release of plutonium had done nothing to radiation levels in the area. But later studies, or later Atomic Energy Commission studies, the revealing of those studies, established that background radiation levels in the area had risen something like 3,500 times. Workers at this site were eventually found to have a brain cancer rate that was 8 times the norm in the greater Denver area, which Golden is about 13 miles north of Denver. And the area continues to be incredibly poisoned. And sort of looking forward in the course, so Rockwell Industries had been able to establish their plant here with federal assistance, and through some of just the basic infrastructure that we talked about, through highways and through other federal spending projects. When Rockwell, when this site became incredibly polluted, Rockwell has spent the last 30 or 40 years fighting every effort of the federal government to claw back money to both pay for the remediation of the site, with costs estimated as high as $100 billion, as well as to pay for the human health consequences. And this is, we'll see, a common trend. So, intended in large part to address these sorts of asymmetrical distributions of power within the workplace, the Occupational Health and Safety Act of 1970 established the National Institute of Occupational Safety and the National Institutes of Health to produce new, supposedly independent knowledge about, among other things, industrial toxicity. But industry battled OSHA over every regulation, forming lobbying organizations like the American Industrial Health Council to challenge OSHA regulations, say, on general carcinogens. These challenges took the form of technical disputes about the validity of the research that the EPA relied on and that OSHA relied on, as well as warnings about the costs of regulation. So they waged a two-pronged battle. One in which they fought about exactly what sort of toxins were being produced, but also this, and this is what I am interested in for my dissertation, this much sort of more diffuse project of convincing both public representatives, both elected representatives, and the general public that the costs of limiting production to account for better environmental protection would simply constrain the economy too much. And this sort of rhetoric became especially effective in the economic downturn in the late 1970s. Now, in the EPA's case, since it was responsible for evaluating new chemicals, the expense of new testing served as a check on regulation. In the mid-1970s, the EPA asked Congress to lift that burden and put it on industry. But industrial lobbying regarding the costs of such a switch eventually produced a program in which manufacturers would notify the EPA when they wished to manufacture a new chemical, and the EPA would conduct this testing. Now, even that limited regulation was too much for some regulators, and following the EPA's decision that a chemical, that a pesticide manufactured by Dow Chemical was in fact not safe for human health. Dow and other companies waged a protracted fight against the EPA in the early 1980s, or in the late 1970s, and with the election of Ronald Reagan in 1980, and his installment of new administrators at the EPA, this challenge to this Dow pesticide was eventually dropped, and they were allowed to manufacture. Recognizing this landscape, this legal landscape that often did not favor them, workers fought toxicity on other fronts, often through strikes or liability suits. In 1973, the Oil, Chemical, and Atomic Workers Union successfully struck the Shell Oil Company with the help of public health advocates and environmentalists, forcing Shell to finance new testing and, what's more, to actually share that information with their workers. Tort suits, another venue that workers use over toxic poisoning, often prove very expensive for companies. And so while regulation was hamstrung by this uncertainty, sympathetic judges and juries often ruled in favor of plaintiffs claiming damage from toxic poisoning. These sorts of tort suits also proved to be one of the main ways that consumers forced suspected toxins out of production, with successful lawsuits pushing products that perhaps could not meet the standards for regulation, but nevertheless proved too expensive for manufacture in light of these lawsuits. Beyond the workplace, beyond these struggles in the workplace, reconciling environmental protection with modern society's dependence on industrial production proved immensely difficult. So, this slide comes from Professor Blackmar, and it's obviously, as you can see, a nuclear energy plant in San Diego. Casting about for less destructive production processes sometimes engendered new dangers. So, nuclear energy is a perfect example of this. While holding out the possibility of developing new fuel sources that would have much less of the adverse consequences that the burning of fossil fuels did, nuclear energy also produced incredibly toxic waste, and waste that had this great salience in the public mind, partly as a result of these long-standing fears over nuclear testing. So the EPA's regulations, in part hamstrung by this continued fighting from industry, and in this case nuclear energy, often addressed the problem only piecemeal, in a piecemeal fashion. So, for instance, regulations on transportation and disposal often focused on particular plants, rather than developing sort of a holistic solution to this problem. And in particular, the question of how long waste were to be monitored and who would be responsible in the event of a accident were particularly contentious. So, before public utilities were willing to enter into nuclear energy, they required the federal government to insure them in the event of a disaster. So they didn't want to be on the hook for potentially billions of dollars worth of damages. And this actually came to the fore during the 3 Mile Island disaster, which many of you might be familiar with, in which a reactor in Middleton, Pennsylvania partially melted down. And though it released only a fraction of the pollution that it might have, the cost, the number of lawsuits that this company faced and the costs that this utility faced were largely shrugged off as a result of these liability agreements onto the government, which has left the government on the hook for much of this remediation. And that disaster, coupled with the public bearing of those costs, helped to sour the public on nuclear energy in the late 1970s. Now, limits on regulation begun during Carter's administration in response to this industrial lobby, and then consolidated under Reagan's administration, often left regulators capable of acting only retroactively in the aftermath of something like the 3 Mile Island disaster. And this impotence in their ability to respond to disaster because they weren't able to take these proactive steps, paradoxically reduced public enthusiasm for regulation further. And so this is a slide that shows how the EPA conceptualizes, or one of the ways in which the EPA conceptualizes the Rocky Flats plant. And what I think is interesting here is this sense in which the problem has been confined. So, and that confinement works